Hello, my name's Liam and I'm with Delightful Computing. Today I'm going to be talking about parsing text with XSLT 3. Thank you very much for being here, for listening, for having me. Some logistics. The slides are available in a variety of formats and typefaces at delightfulcomputing.com/talks. And the one that I'm projecting with is IMFL from the list there, and I'm using it partly because I like it and partly because the irregularities may help dyslexic people. Okay. Slide 3. This talk is not an introduction to parser theory. You don't need to know computer science parser theory for this talk. I'm going to be talking about ad hoc parsing rather than strictly grammar-based parsing. What I mean by parsing essentially is reading a text file and picking out some information. A full parser picks out all of the information, and it may do that based on a set of rules like an XML schema, a grammar. It may well be written by a piece of software, a grammar, a parser generator such as Rex or Lex or Flex. There's lots of them, and they tend to rhyme in X. Ad hoc parsing is where you write one that may be incomplete, or it may be complete but it's not using a formal methodology, or it's not strictly grammar based. The emphasis in this talk is features new in XSLT 3 that make that easier. The examples mostly come from working on a program called Eddy2 that I've been developing off and on over the years. So it's a little less formal approach than some of the other ones we've heard about today in the other talks. Slide 4, Eddy2. Eddy2 is a program that helps you with an analytical based approach to writing XSLT to convert documents that conform to one DTD to conform to a new version of the same DTD. It needs to read both DTDs and compare them. It also reads your XSLT style sheet to guess whether you've written all the templates you need. And it also reads a config file, which is actually just XML. So the main parsing it does itself are the DTDs and the match templates in the style sheet to work out whether you've done what you think you've done. Slide 4 shows an Eddy2 report, and it's a report for an element called role. It's not in the Eddy configuration file, so at this point I needed to update the configuration file to say what I had done with the role element. The list on the right is showing the status, and the role has not yet been handled. Some of the things are in the configuration file, some aren't, some are in the XSLT transformation that I'm writing, and some aren't. The content model here just shows the elements. There's a configuration option to have it sort them within each OR group that was not applied here, so these are the order that they're actually in the DTD, and some of them, as you can see, are in grey. Those ones are because they represent differences between the two DTDs. Those elements are either not in the content model, I guess, of one or other of the DTDs. I don't actually remember what the options were with this run of Eddy, but if you hover over it, it makes it clear. Can't do that because this is a picture. Okay, here's an example taken from a DTD of one declaration. Begins with a less than exclamation mark element, and it ends with a greater than sign, and there's the element name, and then there's what's called content model. And that thing in the middle that says para.level or fn, that's the list of elements in the middle of the thing. Para.level is a parameter entity. So Eddy needs to understand the DTD enough to figure out the parameter entities. It turns out that to get this right, you kind of have to do a token-based parsing. And if that's gibberish, don't worry about it. It basically means you have to parse it a bit at a time. You can't process the parameter entities as if they were a preprocessor and then process the document. That doesn't work. When I'm writing XSLT to handle this stuff, it's really only the resulting list of elements that matters. But those parameter entities, like para.level here in this example, can help the human reader understand the DTD. But all Eddie needs is the list of elements and the original content model to show you. It also wants the expanded content model, again depending on configuration options, because I find that useful in the report. The DTD itself is a text file, so we've got to process a text file. So we all know how to do that, right? The great thing about this being a recorded talk is I can't hear the boos when I move to slide 7 and I talk about regular expressions. So one thing we can do with regular expressions is we can use substitutions to turn input into something regular and handle that instead of handling the input. This does actually work in practice, or would. It's not how Eddie does it, but it would work in practice. So here's calling replace on a constant string just for this example, or the input or whatever. I guess I left out the argument. Would be calling it on the input would be the first argument. Very often in XSLT3 the first argument is implicit, and I'll give more examples of that in a minute. So the regular expression here is element, and then we've got spaces, and we've got \i for an initial letter, \c for a name character, as star meaning any number of them. So I'm matching element name, and then the content model is anything up to the angle bracket, and I turn it into XML elements. I'm kind of skipping some details here. Now in XSLT1 all you could do with this is output it. In XSLT2 actually you couldn't do much more than that either. In XSLT3 we have functions to parse an XML fragment. We can call XSLT on a fragment in a string with fn transform, or again we can write it out. So we've got more flexibility. This is actually useful because we can parse that string to get a tree which we can handle. Because it's the tree we want rather than a parse tree based on the grammar, it's easy to handle. And that's one of the reasons why people do ad hoc parsing, is because you're in control of the data structure you generate. You're not getting back a parse tree based on the grammar. Of course, invisible XML changes that somewhat, and can often be an alternative, but there too you're going to get something back based on a grammar, and I don't want that here because for Eddie my needs are very simple. But how far should you go with this regular expression approach? Regular expressions can get quite long. Arthur C. Clarke might have said, any sufficiently powerful regular expression is indistinguishable from line noise. So you can use whitespace to lay out expressions, to format them. I'll give you an example in a bit using the X flag. You can use intermediate variables, and you can build up expressions from variables. And I'll give you an example of using intermediate variables in a minute. Be careful. Curly braces are special in regular expressions and you end up using them, but they also mark an attribute value template. For example, in the regular expression attribute to analyze string. They also in XSLT3 can be text value templates, for example if they're in the content of XSL variable. So use XSL variable with select equals to build up regular expressions if that's what you're doing. And slide 9, don't do this. This is a real regular expression from production code, and I'm going to just leave it and move on. So slide 10, what can we do instead of that? One thing we can do is we can make a little language of our own and compile it into a regular expression. It's not the original grammar, it's our own little grammar. Or we can use multiple smaller patterns, match one at a time. And we can perhaps do that in a function and using a map to represent what we've done. I'll explain what I mean more about that by a minute. I'm just kind of planting a seed here right now. We can use fn tokenize and match on the sequence of things that we get back. Note that you can't do that to match a DTD because parameter entities turn into things that are not, it doesn't work. I did a separate talk about why it doesn't work, and I didn't do it very well either. For HTML class attributes, don't use tokenize, use contains token. It was written for the purpose, and HTML class attributes, the lowercase Roman letters A through Z and capital A through capital Z are case insensitive, but all other letters in Unicode are case sensitive, so you need a special collation. And so contains token gets HTML class right. It has other uses as well, but that's something to be aware of. People see fn tokenize, and that's a common use I see for it, is matching HTML class attributes, and that's not a good thing to do. Okay. The actual EDI2 DTD parser on slide 11 uses an array of maps to hold a state table. Could actually be a sequence, it doesn't really matter. Except that by using an array I can use the same data structure recursively further down because a map can contain an array as a value. So each of those maps in that array has a string or regex to match the next token. It has a name for error reporting and a function to handle the rest of the construct. So that works because each construct, like element or attribute or whatever in a DTD, kind of has its own little language, so I can give it its own function to handle it. And that can be a parser based on tokens, or it could be a regular expression thing, depending on the item. For a comment, for example, it can be a regular expression, but fairly safely. Similarly, for an element, you can pick out the content model reliably, but then parsing that requires more care. Okay, so the functions can use regexes if you're careful, because they have a kind of limited scope. You know, they can't contain a greater than sign if it's element. If it's attribute, it can. In the default values, you have to be careful. All right. Might be able to. Actually, I don't remember if that's true or not. Someone will correct me if it isn't. Sometimes, though, you have a really simple grammar to match, and using simple replace is super readable, and you can use intermediate variables to help you. So we'll look at an example. I mentioned EDI2 can read your XSLT style sheet and make sure you've got templates where you need them. So we parse XSLT match patterns, things on XSL template elements, to see what elements we're matching. So slide 13 talks about match patterns in XSLT 3, and they're changed. A match pattern is now either a predicate pattern or actually a selection pattern. A predicate pattern looks like a dot followed by an open square bracket and a test and a closed square bracket, and it matches if the test is true, and it can match anything. You can match integers, for example. I didn't even try and parse those. If you're doing something that clever, that's fine. EDI2 won't in fact recognize the example that I've got here, match dot name equals sock. It won't recognize that as matching a sock element. So use match equals sock. If you do want to use predicate patterns, then you can have a template that matches all of your elements that you're treating specially and give it a low priority to shut EDI2 up. which is very much like comments you use it with other systems to shut the linters up. This is not a bad thing as long as you keep them up to date. So I'm still kind of thinking about that. A selection pattern is the one that's interesting though. It uses a subset of XPath. They're the familiar match equals templates that we want Eddie to check for us. They've got a simple grammar. It actually looks more complicated in the spec than it really is. Slide 14 shows some of it. And it's a whole bunch of things I've put in bold, a whole bunch of definitions. So the third one, for example, a path expr p is a rooted path or slash followed by a relative path expr, or slash slash followed by a relative path expr, or a relative path expr. We could simplify that if we wanted to, and I do. We could say it's a rooted path or an optional slash or slash slash followed by a relative path expr. And if we look at a rooted path, which is the fourth line here, then we see it's a variable reference, which will begin with a $sign, or it's a function call followed by an optional list of predicates, the things in square brackets, followed by an optional relative path expression. So if we take rooted path, if we take all this thing on the right of the colon equals, and we replace rooted path up on the third line with that thing on the right, and then we simplify all the relative path expras and the slashes, we discover we've actually got something really quite simple. A path expr turns out to be, if you keep on working, you eventually find it's an axis step at the bottom here, followed by any number of slashes and so on. The reason for going through this is first to say, if you simplify this, it turns out to be much shorter. The reason it's complicated like this is so that an automatic parser can be generated from it, which relies on a token at the beginning followed by something. So we don't need that. If we're using a regular expression, we can use a question mark and move on with life, and the regular expression processor will backtrack for us. And it's not going to backtrack very far, it turns out, because everything either has a symbol like a $sign for a variable reference at the beginning, or a parentheses for a function call, or it is a plain name, which is the thing we're looking for. So that's super easy. But notice that all this grammar is in terms of names with occasional strings, and there's nothing here to make clear that, for example, on the second line you've got the word either intersect or accept followed by a path expression, but you actually need a space in there between accept and a path expression, because otherwise it could just be an element name and you can't say accept div as one word. You have to say accept space div. That's important. Alright, so slide 15 we'll start matching it. I'm actually not going to finish this because I just want to plant the seed. I just want to give you the idea and then talk about it a bit. So at the beginning we remove XPath comments, which are parenthesis colon and colon parenthesis, and we have to do that because otherwise they could contain quotes or square brackets, which would confuse us when at the next step we'll remove strings. Once we've removed strings and comments, we have our variable $without comments, which now will have just XPath syntax in it, and we can in fact blow almost all that away and get a limit and get something that looks like /a/b/c and take the C, and that's the element that's being matched. Or we have, perhaps that's inside vertical bars, A or B, and then we can match two elements. Right, so we get a list of elements back. I haven't shown that here because I've only got half an hour for the talk, right? I do want you to notice that I've got a variable here called noquot_re, which is my second argument to replace here, and giving it the _re helps me make sure that it's a regular expression, that I've got the right variable there. and lots of comments. Now these intermediate variables, you don't actually need them. If you're a mathematician, you may just want to write all this as one expression, then you could. Slide 16. And you could do this in XSLT too, just as easily. But these intermediate variables help me to understand what I did. And I can also print them out. This third bullet point on slide 16 is showing inside those curly braces in the message is $var. So I'm going to get $var equals and then the value of $var, because that's an expression, that's a text value template, and it works rather like an XQuery. It constructs a text node. Or I could look in a debugger such as Oxygen XML Developer, and I've got lots of places to click on to set breakpoints. So it's a lot easier to have those intermediate variables when you're doing this stuff. And my parse returns the original match attribute or an empty sequence, followed by a sequence of 0 or more element names. You might get an empty sequence if, for example, it's a predicate pattern or it can't figure out what's being matched, and or if it was empty. I can use an array here. That's one of our new data structures, so that I can add more information later positionally, or I could use a map and give the items names. The important thing, though, I'll imagine we're using an array, is that if iterate is the empty sequence in the second bullet point in square brackets is an array constructor. An array is like a sequence, except first it's a single item whenever you use it, and second, it doesn't flatten. So if $elements was the empty list, then I would still have an array with 3 items in, and one of them would be the empty sequence. You can also put actual elements, not just names of elements, but actual elements into arrays and maps, and the node identity is preserved. They can contain any sort of item, including function items, which you can't do in elements in our languages, unfortunately. Slide 18 also points out arrays and maps use much less memory than elements because they don't have all those different properties, such as ancestor or schema type. But they're fragile. Maps, pretty much everywhere you use a map, especially if it's heterogeneous, you can't in fact give it your own type name. We don't have a way of naming types in XSL. I know Mike Kay has been exploring going in this direction with Saxon and a putative XSLT4, but right now there's no schema type for maps because maps aren't in schema. That means that if you have a function that takes a map, it accepts any map. And arrays and maps are a little fussy. If you've got a function or a template and you forget to specify the return type, then you're likely to get an error sometime later. Possibly you could use schematron to mitigate this by checking for XSL sequence being used in a template, for example. If it doesn't have an as equals, being able to generate a warning, I'm not sure. Okay, so tables and maps and arrays. Here's table-driven parsing. I can make a data structure. I've left the quotes off the things on the left and the close curly braces off, and there's a lot more detail in the actual one. But essentially, there's an input token and perhaps a parse table or other things can go inside the maps in Eddy in the implementation. And as you can see, I can have maps inside maps and arrays inside maps and so on. So this all makes it sound super recursive, right? Maps can also contain functions. So I can, on slide 20, I can say input token start comment. You actually have to quote the last time probably. And handler. And handle comment #3 is a way of saying I've got a function called handle comment and it takes 3 arguments. That's the function I mean, put it here. So it's called a function item. I could also put the function in line and define it. Handler : in the map, function something or other. It's just an item, it can be a value in a map. That's a bit wild. It's much easier to debug if it has a name, especially because error messages will be in terms of the function name typically, and the error might be detected a long way away from where the function is defined. So I prefer to give them names. I'm very much into readable code that has names for things, because code that's correct today will be wrong tomorrow when the requirements have changed. Okay. And if you see all this stuff with maps inside maps, you may be thinking recursive templates, especially if you did XSLT 1. But unless the interpreter spots how you're using recursive templates, you can run out of memory. And the same with the recursive functions in XSLT 2. So in XSLT 3, we've got this fabulous new thing called iterate. It doesn't actually iterate. It's not really named properly, but what it does is it enforces tail recursion. So it enforces you to put calls to itself back in such a way that I call it strictly loopy. The implementation will turn it into a loop rather than recursion, and it won't use large amounts of memory and it'll go quickly. That's important because parsing can make really deep recursion. Imagine processing a token at a time on a large input file, right, and you're going recursive, and each pass through will handle one or more tokens. But using XSL iterate, you won't have vast amounts of memory going on. Okay, slight change of pace for a moment. Now I said you don't need parser theory. Automata theory or finite state machines are usually taught in undergraduate computer science. If you paid for an undergraduate computer science that didn't teach this, then ask for your money back. And you can see in the background I've got a kind of diagram like a board game, and you move, roll a 6 and move forward. And an example for using this kind of technique, you give each of these circles a name, and you might have a separate set of tables to handle different sections in a book. So you've got a table of contents, you've got a chapter with lots of tables in that you handle separately, another one with lots of diagrams in, another one with definitions, and then you've got another one with discursive text in it, and you treat them differently. Or maybe you just surround them with elements and print and output them for something else to approach. This starts to get closer to a traditional parser, a lot more computer sciencey. So remember who will read the style sheet. Again, I call this the rhetoric of XSLT, how you communicate and who you're communicating to. And XSL iterate can make this kind of thing go really easy with functions that handle the different sections or templates. Sometimes you're processing something large, and you might have a map with 1 million keys in it, for example, for processing some encyclopedia, or you've got every word in the encyclopedia is given a separate word, is given a separate key because you want to count them. And here XSLT3 gives you things like map colon for each, and also map colon fold left, and you can also use the exclamation mark operator. So use the map colon keys function, and the exclamation mark will pass one key at a time to your function that you pass next as the first argument. There's also an operator equals greater than, which will collect all the keys, or 6 million of them or whatever, and then pass them to the function. With the exclamation mark, they're passed as the context item each time, so it's a bit like slash in path expressions, and that's how you can kind of remember it's different. And with equals greater than, they're passed implicitly as the first argument. And I mentioned before in XSLT3, very often the first argument's left off things because of that. Okay. Another way you can deal with large maps is using streaming. And if you do anything like that, look at streaming. If you run out of memory, look at streaming. But streaming also has some super useful stuff. Where populated will generate a wrapper element only if you've got children of the wrapper element. So consider generating a list, and you only want to generate the list element if there are children. And you might have done that by generating it into a variable and then doing a test. But this is much easier to read, it's more elegant, and in fact it uses much less memory. It's streamable as well. We have higher order functions in XSLT3 so that you can write functions that take functions. I'm not going to go too much into this, but I wanted to mention it here. In particular, you can make a thing called a visitor pattern, where you have a function that walks a tree in a particular way and it does something. The something it does is parameterized by handing a function that will do the thing. So it actually turns out to be a pretty useful kind of technique once you get your head around it. Okay, I didn't want to go suddenly more computer sciencey right at the end. So let's summarize a bit. We've looked at some new data types, maps and arrays. We've looked at new operators. We've looked at higher order functions a little bit, functions as values. We've looked at streaming. I've talked about templates that can return functions or arrays or maps. My head's spinning, I don't know about yours. Big and deep changes. Number one, always keep in mind the rhetorical nature of what you write. Be careful if you get too mathematical or too computer sciencey or too programmery. Ad hoc parsing of text is nothing to be ashamed about, I insist. And XSLT3 brings lots of tools to help you. Oh, and if you're wondering, Eddie 2 is doing fine. Thanks for asking. So, thank you for listening. LiamQuin, Delightful Computing. And it is time for questions. Thank you.